Hello again. We're moving on to a topic that you may have heard of in geometry, but we're going to touch on it again here. It's the converse, the inverse, and the contrapositive. This is lesson 5.12. So let's get started. The converse, first of all, is if you start off with an if-then statement that says if P then Q, or P implies Q, then the converse of that is what you get when you switch the two parts of that sentence. So instead of P implies Q, you get Q implies P. So for example, the converse of if it snows, then it is cold would be if it is cold, then it snows. So you just switch the two parts, leaving the if and the then where they are. That's how you make the converse. Okay, there's the truth table for it. I don't think I need to get into that, but if you do have questions, please let me know when we see each other tomorrow. Then we have inverses. Inverse of P implies Q is not P implies not Q. So an example of that is if it snows, then it is cold. That just means you negate each part. You don't change the order or anything like that. You just say the opposite. So instead of if it snows, then it is cold, we say if it doesn't snow, then it isn't cold. And so here's the truth table for that one. All right, and I want you to notice that the converse and the inverse, the last column looked exactly the same. So I want you to understand that those two are logically equivalent based on our definition a couple of sessions back. Then we have the contrapositive. Contrapositive of P implies Q is where you switch the parts and you negate both parts, leaving the if where it is and the then where it is. So P implies Q becomes not P implies not Q. So for example, if it snows, then it is cold. The contrapositive of that is if it isn't cold, then it doesn't snow. All right, and here's the truth table. I want you to recognize that as being the same as the truth table for the original sentence that I started with. If it snows, then it is cold. Or if P then Q, or P implies Q. Those two are logically equivalent as well. All right, so in summary, we've got P implies Q, so there's the original implication. If it is 30 degrees Fahrenheit, then it is freezing. The converse of that would be if it is freezing, then it is 30 degrees Fahrenheit. Not necessarily true, even though the first implication actually was. The inverse says if it isn't 30 degrees Fahrenheit, then it isn't freezing. Well, that's not really true either, for the same reason that the converse wasn't necessarily true. And then the contrapositive, if it isn't freezing, then it isn't 30 degrees Fahrenheit. And that is as true as the original implication. So you can see the pairs of statements that are logically equivalent here. The two that are red, that have red arrows pointing to them, those are logically equivalent. And then the two that have blue arrows pointing to them, they're also logically equivalent. So if you have any questions, please let me know, and I will see you tomorrow.